Imagine a visitor from another star system. A frozen traveler that has been drifting through the cold darkness of interstellar space for billions of years, suddenly dropping into our solar neighborhood. And as the James Webb Space Telescope turns its golden eye toward this ancient wanderer, it finds something extraordinary. Something that rewrites what we thought we knew about where life's ingredients come from. Welcome back. Today we are talking about one of the most quietly stunning discoveries in recent memory. The James Webb Space Telescope has detected methane on an interstellar comet. Not a comet from our solar system, an object that formed around another star entirely in another part of the galaxy and somehow made its way here. And the implications of that single detection stretch all the way back to the very origin of life on Earth. Let's set the scene. In 2019, astronomers spotted a fuzzy smudge moving through our solar system at an angle and speed that didn't make sense for anything born here. They named it 2I/Borisov, the second confirmed interstellar object ever detected, following the mysterious Oumuamua just 2 years earlier. Unlike Oumuamua, which came and went before scientists could study it properly, Borisov lingered long enough for telescopes around the world to take a good hard look. It behaved like a comet, it had a coma, a tail of gas and dust, the whole performance. But it was a comet from somewhere else entirely. A genuine alien comet. And now, years later, Webb's infrared eyes have done something no telescope could do at the time. They've gone back to archival data and extracted a chemical fingerprint from Borisov's coma. And one of the molecules hiding in that fingerprint is methane. Carbon and hydrogen. CH4. Simple, yes. But the story it tells is anything but simple. Here's why this matters so much. For decades, scientists have debated how Earth got its volatile molecules, the stuff like water, carbon dioxide, organic compounds, the raw materials that eventually led to life. One leading theory is that comets delivered much of this material during a period called the Late Heavy Bombardment, roughly 4 billion years ago, when our young solar system was a chaotic, collision-filled place. Comets slamming into early Earth could have seeded the oceans and the atmosphere with the building blocks of biology. But here is the question that has always gnawed at scientists. Were those molecules unique to our solar system? Or are they universal? Are comets everywhere around every star, carrying the same cosmic chemistry? Borisov just handed us an answer. And the answer is yes. The detection of methane on 2I/Borisov tells us that this comet, born around a completely different star, assembled from completely different dust and ice, carries the same kinds of volatile organic molecules that we find in comets right here at home. The chemistry isn't unique to us. It's baked into the fabric of how planetary systems form across the galaxy. Now here's the part that really should make you stop and think. Methane isn't just some random molecule. In the context of comets and planetary chemistry, it's a marker. It tells you something about the temperatures and conditions under which the object formed, deep in the cold outer reaches of a star system, where carbon monoxide and carbon dioxide can react and freeze into icy grains. Finding it in an interstellar comet means the processes that built our solar system's comets aren't special. They're standard. They're universal. This shifts the entire framework of how we think about life's origins. If the same chemical ingredients are being assembled in the same ways around stars throughout the Milky Way, then the delivery mechanism for life's precursors isn't a lucky accident that happened once, here around our sun. It's a cosmic process. A galactic-scale chemistry experiment running simultaneously in billions of locations. And now for the perspective shift, the moment I want you to really sit with. Every time a planetary system forms, it creates not just planets, but also millions of comets. Many of those comets get flung outward by gravitational interactions, cast into the void between stars. They become interstellar travelers. Which means the galaxy is constantly, right now as you watch this, being seeded with tiny frozen packages of organic chemistry, drifting from star to star, solar system to solar system. Borisov was just one visitor we happened to catch. Scientists estimate that at any given moment, there could be thousands of interstellar objects passing through our solar system that we haven't detected yet. Trillions have passed through over Earth's entire history. Think about that. The molecules that may have helped spark life on Earth might not have originated in our solar system at all. They could have hitched a ride on a comet that was born around a completely different star, ejected into the dark, and eventually captured by our sun's gravity billions of years ago. Life on Earth might be, in a very real sense, made of stardust from a star we'll never see. And Webb is just getting started. The telescope's ability to analyze the chemistry of distant, faint objects with this level of precision is unprecedented. Scientists are now refining their chemical inventory of Borisov and comparing it with comets from our own solar system like 67P/Churyumov-Gerasimenko, which the Rosetta mission studied up close. The early comparisons are striking. The chemical ratios are remarkably similar. Different star, different time, different place in the galaxy. Same recipe. What this means for the search for life beyond Earth is profound. If the building blocks of life are being distributed universally by interstellar comets, then the question of life's origins isn't just a question about Earth. It's a question about chemistry. And chemistry, as far as we know, follows the same rules everywhere in the universe. The same atoms, the same bonds, the same reactions from here to the edge of the observable cosmos. We used to think of life as a miracle, a rare, fragile flame that somehow flickered to life in one special corner of one ordinary solar system. But every discovery like this one nudges us toward a different picture. A universe that is, in some deep and fundamental way, trying to create life. Seeding the darkness with the molecules of possibility, again and again, across unimaginable distances and timescales. Borisov came from another star, carried the same chemistry we have here. And Webb saw it. That single observation, a faint infrared signal in a smudge of light passing through our cosmic neighborhood, quietly shifts the odds. Not just for life on Earth but for life everywhere. We are not an island. We are part of a galaxy-wide conversation written in the language of molecules. And we are only just beginning to read it. If this blew your mind even a little, hit that like button. It genuinely helps this channel reach more curious people just like you. Subscribe if you want to keep exploring the cosmos together because we are just getting warmed up. Drop a comment below. Do you think interstellar comets could have seeded life on Earth? I read every single response. And stay tuned because next time we're going even deeper into the mystery of what Webb is revealing about the atmospheres of exoplanets, and whether we might be closer than ever to detecting signs of life beyond our solar system. The universe is full of secrets. Let's find them together.